When an ionic compound or salt, as we like to call it, dissolves in water, for example sodium chloride, we tend to visualize that this crystal lattice structure made up of cations and anions ionically bonded to each other dissociates and is hydrated to form an aqueous solution. Aqueous because the solvent is water. Aqua meaning water. The positively charged sodium cations are attracted to the negatively charged regions of the water molecules, specifically the oxygen portion, as it is highly electronegative, so tends to hold the electron in its covalent bond to the hydrogen atoms, therefore gaining a slight negative charge. Similarly, the negative charged chloride anions are attracted to the positively charged regions of the water molecule. In this case, the hydrogen parts, as they have a slight positive charge due to their extremely low electronegativity. The same thing happens when solid silver nitrate is dissolved in water. We should visualize that this ionic lattice is pulled apart by the attraction of the water molecules, the silver cation being attracted to the negative polar region around the oxygen atom, and the nitrate being attracted to the positive polar regions around the hydrogen. In both examples, the sodium chloride and silver nitrate remain as aqueous solutions. However, if the two solutions are mixed, ions floating in solution have an opportunity to react with one another. The positively charged sodium ion can be attracted to the negatively charged nitrate ion, but it isn't, because the attraction to the water is much stronger, so they don't react, they don't bond. Take away the water, and it's another story. But we also have the positively charged silver ion, which can be attracted to the negatively charged chloride ion, and they are attracted. The electrostatic attraction between the silver ions and the chloride ions are greater than that of water, so they are taken out of solution, forming a precipitate. This is known as a precipitation reaction. In most precipitation reactions, the ions replace each other based on their charges as either a cation or an anion. This can be thought of as switching partners, that is, the two reactants each lose their partner and form a bond with a different partner. So in our example, the switching of anions and cations can be represented by the full equation, but if we focus on each ion as it plays its part in the reaction, it can be expressed using a full ionic equation, noticing that the silver chloride precipitate is combined. However, there is no change with these ions, as they haven't really reacted. These are known as spectator ions. Since they haven't reacted, we can represent this precipitation reaction using a net ionic equation, which only involves those species that have reacted.